Alright guys, so we're going to go ahead and start chapter 3, and I think you guys are really going to like this. So up to this point we've been talking about linear functions, right? And we talked about point-slope form, slope-intercept form, we talked about standard form, and how we can know if slopes are parallel or perpendicular. Well, today we're going to go ahead and start with chapter 3, and 3.1 talks about functions and relations. So, a relation, alright, is a set of ordered pairs. Set of ordered pairs, okay? The difference between a relation and a function is a function, each input, okay, or x, has exactly one output, y. Alright, so each input has exactly one output. If you memorize this, you will be great. Alright, so let's talk. Domain goes left to right. Our domain is our x values, or our inputs. And our range goes up and down, okay, which refers to our outputs, or our y values. So, domain, range. Set builder notation. Continuous or discrete, we're not going to go over this. You can go ahead and scribble that out. That's for Algebra 2. But set builder notation. So you might be saying, well, we just went over interval notation, okay, this last chapter. Yes, this is very important in algebra. Set builder notation is another way to describe what's happening to the graph. So set builder notation is when you describe a set of numbers by listing, showing math symbols, or using words. So here's how you would say this. P, so that P is the number of all people with black hair. X, so that X is less than 2. And W, so that W is all whole numbers. Alright, a friendly reminder, interval notation is when you describe a set of numbers by showing the range of numbers with the lowest value to the left to the highest on the right. So we talked this last chapter about the difference between a parentheses and a bracket. A parentheses means that that number is not included in the set, but it gets super, super close to it. And a bracket means that that number is included in the set, or it hits that number. So an example, this says 1 with parentheses. That means it gets super close to 1, and it's going to hit 9. 9 is included. It means from 1 to 9, but not including 1, it is including 9. Here we have two brackets, so it means it is hitting, or it is including negative 45, and it does include 0. Here, super duper close to negative 6. It goes all the way up to infinity. Okay, but it's not including negative 6. It just gets super duper close. So let's look at a couple examples. Alright, example 1. Sorry, that's kind of crooked for you guys. Example 1. You're going to see here they list a bunch of ordered pairs. So the first question they ask us is this a relation or a function? So we're looking to see our x values here, if you make a table, if our x values have exactly one y value. So we have 4, 1, we have 5, 2, we have negative 6, 3, we have negative 10, negative 1, we have 3, 1, and negative 4, 12. So is this a function? Yes, this is a function. Why? Because each x value only has one y value. So each input has one output. So domain. Remember, your domain is going left to right. So if you want to show yourself, okay, that's going to go left to right. That is going to be our lowest to highest. So set builder, watch this. X. So that x is negative 10 is our lowest number. Then negative 6. We have negative 4. It looks like 3, 4, and 5. Okay, so x, so that x is equal to these numbers, lowest to highest. Okay, interval we'll do on the next page. Range. Okay, range is always our y's, so it's going to be y, oops, squiggle, y, so that y is, again, lowest to highest. We have a negative 1. We have a 1, 2, 3, and 12. And you might be saying, well, Ms. Widerski, you missed a couple ones in there. You only need to list it once because you're saying it's including that. So you don't need to list 1 3 times. Just once will do the job for that. If it is a function, discrete or continuous, we can cross off E and F. You guys will be doing that in Algebra 2. And on to the next page. I really like when they give us numbers like this in the boxes because it lets us know where everything's at. So I always look at this and say, okay, is this a relation or a function? So I'm going to look at my x values. Okay, each x value has exactly one y value. So yes, it's a function. X is not repeating itself, so that means each x value has exactly one y value. Y, each input, or x, has exactly one y value, which is our output. Domain, set builder. Okay, that's our x values from least to greatest. So x, so that x. So set builder x, so that x is equal to, well, lowest to highest is equal to -8. -6, it looks like we have a 2.1, a 4, a 5, and a 10 for x, squiggle. Interval. All right, for this one, they would like to know what is the lowest the number can be. Well, it's going to hit at -8, and the highest it can be is 10. Brackets. We're going to use brackets for that because it's hitting that number. That number is included. All right, range, set builder, squiggle, y, so that y is equal to lowest to highest. We have a -7, a -5.6, a 2, a 6.4, an 8, and a 12. Squiggle. Interval. Lowest number we can have for the y's is -7. Highest we can have is 12. Use those brackets. E and F, again, you'll come back to that in Algebra 2. All right, number 3. Is this a relation or a function? Well, I'm going to introduce something called the vertical line test. Okay, the VLT, vertical line test, is great when you have a graph. Okay, so if you draw a bunch of lines, let's just look at exactly this line right here. Okay, A. If I have a bunch of lines that go like this, up and down, they're vertical. Okay, if I'm looking at my graph, just this line, all right, and it's not hitting more than once on here, okay, we're not looking at this other line, just this one, each input has exactly one output. So we know this is a function, A. Why? Because this, if I have the vertical line test, and I'm going up and down, my pen on this line is not hitting any other point on that line at once. So this is going to be a function. Okay, and the reason why, each input has exactly one output. Okay, we'll talk the next couple days about, well, what if we were to put this line in here? How is that going to change, okay, our relation and function? But for now, we're not looking at B. We're just looking at line A. So domain, okay, we need to figure this out. Domain is always left to right. X, so that X. Well, let's take a look. It looks going left to right that the smallest X can be is going to be 0. So it has to be greater than 0. Greater than or equal to 0 because it hits at 0. And the highest this number is going to the right looks to be about, we're going to say 2.5? Nope, 3.5. Let's see. Draw a straight line. 3.5. Okay, so the highest it's going to be, X has to be greater than 0, and X has to be less than or equal to 3.5. Squiggle. Alright. Interval, the smallest X can be is going to be 0. The largest it can be is 3.5. Range, right, is the values going up and down. So let's take a look. The highest Y value you have looks to be 80. Alright, so my range then will be squiggle. Y, so that Y has to be greater than or equal to 80. And the highest my Y value is going to get looks to be about 300. So, and Y has to be less than or equal to 300. Squiggle. Interval, Smallest my number can be is -80. The greatest is 300. Squiggle out E and F. All right. I'm going to have you guys do number 4. All right. And I'm also going to have you draw something out with me. So for number 5, we're going to talk about this one in class tomorrow. If I were to give you a graph like this, okay, and I were to give you, oh, you cannot see that, and I were to give you something like this, and we'll say this is 1, 2, 3, and 4. Okay, the first one, or the first question I want to ask you, is this a relation or a function? And just by looking at this, if I do that vertical line test I talked to you guys about on the previous page, I'm going to use a different color so you can see this. Okay, if I were to have a bunch of vertical lines going up and down, okay, is this a function? No. Why? Because I have 2, so it's not a function, it's a relation. And the reason why is because I have 2 inputs, or 2 x values, with different y values. Okay, so I have 2 inputs, or x values, with different y's. Okay, I want you to go ahead and determine if the following are functions or not, and why. All right, so number 6. Here's my graph. All right, tell me, is this a function? Why or why not? Okay, number 7. I want you to tell me if this is a function. Okay, and number 8, I would like for you to tell me if this is a function. Why or why not? So let's make up some numbers. Today's the 20th. It's almost October, which is 9. We've got -18, 2, 6, 5, -21, 4. We'll say 26. We'll have 0, 5, and, ooh, you can't see those, 9, 3. Function, why or why not? All right, so I'm going to look tomorrow for number 4, 6, 7, and 8 in your notes.